Alright, 5.3, increasing and decreasing functions in the first derivative test. So you, this is pretty straightforward, these two definitions here. If you ever looked at the graphs and remember what an increasing and decreasing function looks like from your algebra days. But this is just what I have written down. I recommend you pause this and jot it all down. But the function f is decreasing on an interval if for any two numbers x sub 1 and x sub 2 in the interval x sub 1 is less than x sub 2 implies f of x sub 1 is less than f of x sub 2. What does that mean? Let's say here x's are 1 and 2, right? And 2, of course, is bigger than 1, right? So, if your output for 2 is bigger than the output when you input 1, it's increasing, right? Because your graph would be doing, going up, right? It's getting bigger. As opposed to decreasing, where same definition, except if f of x sub 1 is greater than f of x sub 2, then it would be decreasing, meaning 1 would be bigger than what 2 was. So it would be, therefore, decreasing. And kind of this whole idea behind most of this chapter is that we can use derivatives to kind of help us with some of the basic things that might be kind of hard to see. And that's, in this case, finding out if a function is increasing or decreasing. So if we find a derivative of f of x, and the derivative of fx at any given point for x, if it's greater than 0, it's increasing. Less than 0, it's decreasing. If it's equal to 0, it's constant. Now, what does that mean? So if we find a derivative of some function, and when we look at, like, for example, x equal to 1, if we put 1 into the derivative function, if it's greater than 0, it's increasing. If it's less than 0, it's decreasing. So we got this function right here. What I want to know is, when is f of x increasing or decreasing? So let's find a derivative of this function. I'm in laser mode. There we go. Derivative is going to get us 6x squared plus 6x minus 12. So I need to find out when it's equal to 0, because that's going to be, so whenever we find a derivative, we need to find the zeros afterward, because that is going to be when it potentially changes from increasing and decreasing. Not always, but that's when it could potentially switch from increasing and decreasing, or vice versa. So let's factor out GCF. I'm going to get rid of 6 to make our lives a little easier. Cool. And this is an easy factoring one. Yeah. So x equals negative 2 and 1 are going to be our zeros in this case. So what does that mean for us? So let's set this up. It's usually easier with a table of some sorts. I know I'm kind of running out of space, but you'll get the picture. So negative 1 is the smallest, so from negative infinity to negative 2, negative 2 is the smallest. My apologies. Negative 2 to 1. And then 1 to infinity. Now, what's our goal with this? Pick a point that holds true for this, okay? For in this, and this, and we're going to plug that value into our derivative function. It might be a little easier when we do the factored out 6, right? Because we factored out a constant, which is cool. So we put it in there. If it's negative, it's decreasing. If it's positive, it's increasing. So when I'm going to test that's less than negative 2, let's be simple. Don't do anything crazy. Let's test x equal to negative 3. For here, I'm going to do x equal to 0. It's everyone's favorite. And then let's do x equal to 2 for over here. So we put negative 3 in. Remember, I'm doing the derivative function. If you want to do this, that's fine. I'm going to go down here, though, because we factor out a 6. Now, if I factor out a 6x, I'd have to put it in there, too. But if I put negative 3 in here, that would be 9 plus negative 3, which is 6. 6 minus 2 is 4. So your output's 4. Is 4 greater than 0? It sure is. So therefore, from negative infinity to negative 2, your function is going to be increasing. 0. So the derivative of f of 0 is going to get us negative 12. And negative 12 is less than 0, so therefore you're going to be decreasing. And then derivative of f of x at 2. Put 2 in. 2 squared is 4. 4 plus 2 is 6. 6 minus 2 is 4. 4 times 6 is 24. 24 greater than 0? It sure is. So therefore it's going to be increasing. So when is this function increasing? It's increasing from negative infinity to negative 2. And 1 to infinity. And it's going to be decreasing. When's it decreasing? From negative 2 to 1. Okay? Now, if you remember from previous sections, we talked about how when we find a derivative and the values of x that make the function 0 are your mins and maxes, with the first derivative test, what we're going to do is we're going to do one better, okay? I'm going to say whether it is a min or a max, not just the fact that where it's at 0, that's a min, that's a max, okay? So we want to know whether it's one or the other. So 3 steps, or 3 things you need to know about the first derivative test. So the 3 possibilities are here. Pause, jot this down, all that good stuff. So let's look at think about the example before. Okay, hopefully you wrote it down and just didn't like listen to this. But look at the first one. It says if the derivative of f of x changes from a negative to a positive, then f has a relative min at c comma f of c. So in that previous problem, that would be at x equal to 1 because it goes from a negative value to a positive value at x equal to 1. So 1 would be your relative min, as opposed to negative 2, which would be relative max because it changed from a positive to a negative. So therefore be a relative max. And if the derivative of fx is either positive both sides or negative both sides, it's neither a max nor a min. That's why I said whenever we find the zeros of your derivative function, it's not always going to work out that it's going to be a min or a max. We have to test it, okay, to make sure. Let's find a relative extreme. Let's do this, okay? So, let's use blue here. Derivative of f of x, we have to find the derivative first. Doesn't go away. 3x squared minus 12x. And then we got a factor. GCF, we love GCF. And x equals 0 and 4 are your zeros. Let's make our fun little chart. 0 is the smallest, so we go from negative infinity, that's a terrible infinity sign, forgive me, to 0. And then we go from 0 to 4. And then 4 to infinity. So, pick a value less than 0, let's do negative 1. And between 0 and 4, we can't pick 0, that's sad. Let's pick 1, and then greater than 4, let's pick 5. So we put negative 1 in. That's going to be a positive, it's going to be a 15. Put negative 1, it's going to be 15. Is 15 greater? 15 is greater than 0, so it's increasing. Nice. At 1. So we plug it into the 1 function. Negative 9. Negative 9 is less than 0, so therefore it's decreasing. And then 5, we put 5 in, and you're going to get 15. Hey, 15 again. How about that? 15 is greater than 0, so it's going to be increasing. So what can we conclude about our relative extrema? So we're going to have 2 of them. 0 comma something and 4 comma something. Put 0 comma something is 15. And then 4 comma something, negative 17. Okay. So These are mins, maxes, what? So right here at x equals 0, we are swapping from increasing to decreasing. That's going to be a max. Relative max, relative max. And then we got a relative min because it's switching from decreasing to increasing. Okay. Alright, let's do this one as well. So derivative time. Bring that 2/3 up front. Negative 1/3 here. And derivative of the inside just 1. So it works out nice. So it's just going to be 2 over 3 parentheses x plus 2 to the 1/3. And so what values make this undefined or 0? That would just be negative 2. So this is an easy chart then. We lucked out. Negative infinity to negative 2 and negative 2 to infinity. So let's test. Pick a number less than negative 2. Let's pick negative 3. Pick a number greater than negative 2. 0. We put 0 in. Your output's positive. Okay, I don't know what the third root of 2 is, but it's a positive number. Okay, which is important. So since it's greater than 0, it is in fact increasing. For negative 3, put negative 3 in. Third root of negative 1 is negative 1. That's negative 2/3. And negative 2/3 is less than 0, so therefore it is decreasing. So since switching from decreasing to increasing, what can we say? At the point negative 2, comma, in this case it's going to be 0. Since switching from decreasing to increasing, it will be a what? A minimum. Relative minimum. Okay. Alright, let's make our lives a little easier with this last one we're going to do together. What I'm going to do is I'm going to divide each of them individually by x squared. So it's going to be x over x squared plus 4 over x squared. And we are going to be finding, I'm not finding derivative yet. I'm going to go to the side here. We got x in negative first plus 4x in negative second. Now, derivative time, negative x in negative second, negative 8x to the negative third. And now I will get a common denominator after we throw these in the bottom. And then common denominator will be negative x minus 8 over x to the third. Now what values make this undefined or 0? That would be x equal to negative 8 and x equal to 0. So we make our chart. And we're going from negative infinity to negative 8. Negative 8 to 0. And I'm going to test points, so let's try negative 9, negative 1, and 1. And see what happens. So we put negative 9 in. We'll get a negative on the denominator and a positive on the numerator. It's going to be a negative value, okay? So f prime at negative 9 will be less than 0. So therefore, you're decreasing here. And then we put -1 in. It's going to get us a negative on the bottom, negative up top. So it'll be positive. So f prime of -1 will be greater than 0. Increasing, and then 1, you get, it'll be a negative over a positive, so it'll be negative. So it's decreasing. So what does that mean? I'm going to go up top here to say what our extreme are. So we're looking at -8. And 0. And we put 0 in. 0's undefined. Oh no. -8 gets us 1 over 64. -8 comma 1 over 64 would get us a what? Or not 1 over 64. Wait. 1 over 16 rather. My apologies. -1 over 16. What does that value represent? So it's going from decreasing to increasing. That would be a minimum. Relative minimum. Okay, and about that 0 point. As for 0, 0 is not in our domain. Okay, not in the domain of the original, so therefore it is not going to be a min or max. Okay, that's it. We're done. This is your only answer. I appreciate you watching, and we'll see you later. Bye-bye now.